All right, good day, everybody. I've, excuse me one second. I went to the dentist today and had a little gauze in my mouth. So right now I want to further this by saying we're going to 10.3. And this is fairly straightforward. I hope you find it on the easy side. And I just get started with some of these problems. Now these problems are reflective of your homework problems, even by number. So they're similar, if not the same, as the ones you have in your homework, which is okay, but just notice what we're doing as far as paying attention to the properties and the rules that we're following. Alright, so here we're saying with number 1 that when we are, the title of this is multiplying these rational exponents. So when we multiply them, we can take note that we can multiply these together provided that the index numbers are the same. And if these indexes are the same, then we can just multiply the integers of 7 times 2. So in other words, this would give me what is the square root of 14 would be the question. And then we always simplify things whenever we can. So this is simply 7 times 2 in the square root sign, which gives you square root of 14. If I could, I would simplify this in its entirety, but I can't, which is noted by the 7 and the 2 that we multiplied. So this would be my solution for that. Alright, so moving on here, here's my index numbers of 4, they're the same. So I just multiply these two and I get the question, what is the the fourth root of 16? And I'll check that, do the factorization of 16 to see if I have 4 roots for it. So I'll do the tree branch method and I can see I've got 2 times 2 here, 2 times 2 here. So that means the fourth root is 2, because for every 4 2's I have, I take 1 out. So my solution would be 2, similar to what I do in class. Okay, so there we go. So again, if you don't need to break these down, I like to emphasize the breakdown for students that are struggling with this at all. So if you know this from doing problems right from the get-go, you're good to go with that. How about this one? The third root of 4 times the third root of 9. So that's going to give me, I'll write it down here, the third root of 36. Okay, so let's see, what have I got here? If I factor the 36, I'm just going to continue it down here. So let's see, I think of 6 times 6, right? And then 6 would give me 3 times 2, and this 6 is 3 times 2. So I don't have 3 factors that are the same that give me 36. I don't have that, I just have 2. So my answer would just remain the third root of 36. Fooled me on that one. Okay. Let's go on to this next row of problems. So here, what do you think I'm going to get here? I'm going to get numerator denominator, so I'll have 7 times 2 is 14 over xy, which is x times y, which is xy, and that's all I can do with this. I don't have a square root of anything that I can take out. Here on the other hand, alternately, I could write this up too as the square root of 6 divided by the square root of 49, if you wish. And the square root of 6 is the square root of 6. I'm going to go down below here to write that. Is the square root of 6 divided by the square root of 49. I'm going to redo this. I don't know, I'm kind of linear, I guess you'd call myself. So here I have the square root of 6. I can't do anything with that. And then the square root of 49 is 7. So there I arrive at my answer. This problem here, number 6, is similar, where if you rewrite this to be the square root of 2 over the square root of 49. Equal expressions, so the square root of 2 remains the square root of 2, and then the square root of 49 is 7. Whoop. Where am I here? How about this here? So here I've got, let me rewrite this to be the cube root of 4 over the cube root of 27. So that should give me the cube root of 4, can't do anything with it, but the cube root of 27 is 3. Okay, and then so we got that. Moving on, this would be the square root of x squared y over the square root of 169. And from here I'm going to get, let's see, the square root of x squared would be, take 1 out, I'm going to do it down here again. So that's going to be, should I rewrite it? Yeah, darn. X squared y over the square root of 169. Alright, so back up to the top here, I've got an x can come out, and then what remains inside is the y, and that's going to be over the square root of 169, which is 13. Okay, a little bit more involved on that one, but you get the idea. Number 9, this is not the index number. This is 5 times the square root of 75. So I can leave the 5 out here and determine what is the square root of 75. So I'll take my 75, maybe throw it over here and do the factorization of that. So what is that? 3 times 25. Okay, so here I got the square root of 25. So that means I'm going to have another 5 come out. And what's going to be left is the square root of 3. Remember, 25 is 5 times 5. For every 2, take 1 out. There's the 1 I'm taking out. And what remains is the 3. Oh, and by the way, I have 5 times 5 now. So now I can multiply that to give me 25 root 3. Okay, moving on. You can see this is not bad at all. I hope you feel that way again. Let me, got these kind of scrunched in here. Let me see what I can do here. Alright, let me just do it this way. Alright, how about the third root of 16? So we've got, I got a variable in here now, just slightly different than we've had before. So 16 with 16, what can I do with that? I've got, we know from doing it before, it was 2 times 2 times 2 times 2. And then the y to the 7th, I'm not going to expand that. Excuse me. So let's see, if I have the cube root, for every 3 I'm going to take 1 out of the 2, so I'm going to have 2. And then I know on the inside here I'm going to have a 2. That's this one left over. It goes back under the radical sign. And then with the y to the 7th, I got to divide the 3 into the 7. So 3 goes into 7 2 times, and that gives me 1 left over. So what does that mean? I'm going to take out a y to the second power. I'm sorry, to the third power. And then I'm going to have 1 y left over. That's better. I have 7 of them. For every 2 I take 1 out. So here's my 3 to give me 6 of them. and then the 1y that's left over will remain. So this will be my answer for number 10. Okay, moving on. For the cube root of 125 r to the 9th s12, this is an s. So I know the cube root of 125 is 5. That comes out front. And then I've got r to the 9th. So that's going to end up being r cubed, because we just do division here, right? 9 divided by 3 is 3. And then s to the 12 divided by 3 is 4. So this is a perfect square root, and that's what I end up with. I'm sorry, cube root, not square root. Number 12 over here, let's see how this fares. This is the 4th root of 32. 4th root of 32 has got to be, well, we said 16 over here was 4 2's, so this must be 5 2's over here. So this would be 2 times 2 times 2 times 2 times 2. 2. And again, I'll leave the variables alone here. We can just do division for that. So for this then, for the 4th root, I've got, for every 4, take 1 out, so 2 comes out front. And then I've got what? Something left inside, which is this 2. So that'll remain inside. Then our variables, I have 12 divided by 4 is 3. So I got x cubed here. And finally, 5 divided by 4. Well, 4 goes into 5 one time. There's our 4 y's that we need. That comes out here, the one time, and then there's going to be 1 left over, and that'll go inside. Okay. So remember, if I'm not saying this to your liking, remember to expand that. You know, for example, the y's. There's 5 of them, just like there was 5 2's here. But I can only take out 4 because that's what the index number is. So for every 4 I take out 1, there's the 2 I took out. For the y's, there's 5 y's, so for every 4 I take 1 out, and there's the 1 I took out, but 1 remains inside underneath the radical sign. Okay, how about this one? Now when we get to here, I've got the indexes that are the same. See, so when we multiply, we can multiply them across like we did at the start of this section. Same with division, provided my indexes are the same. Now I've got numbers here that are divisible, and so I can write this up as, let's see, the cube root of 24 divided by 3 is 8. And then I have to check, can I simplify that cube root of 8? 8 is a cube number, so the cube root of 8 is 2. Okay, and that would be my answer for number 13. Here's another one. Same index as division problem, a fraction. I can simplify that now, and that'll give me, I'm going to do it down here, so that's going to give me what? I'm going to have x to the 5th divided by x to the 1st. That gives me x to the 4th. Quotient rule I'm thinking here. Y to the 3rd divided by y is y squared. Okay? So I combined them, but I'm not done yet, because now I got to look inside here to say, what's the square root of x to the 4th? It's x squared. I'm going to bring that out front. What's the square root of y squared? It is y. So they divide evenly, so this would be my solution. Square root of x to the 4th is x squared. Square root of y squared is y. Done. And finally, number 17, I went on a sequence here for, because you get the idea, I'm not going to do all these, they kind of get repetitive. So here I'd end up with the square root of 2. 14 divided by 7 is 2 with the radical sign. look at the square root of 2. Can I simplify that any further? The answer is no. Okay, that is section 10.3. See you in the next section.